Hello all, welcome back to Current Affairs Atlas series. I'm Guna Mathivanan from Officers IAS Academy. Today we are going to discuss one interesting topic that is regarding LK99. So to understand about LK99, we should know some basics. Okay. So first we will take an atom. Everything in this universe, you and me also, this pencil also, everything is made up of atoms, right? So each atom will have a nucleus. We all know at the center of the atom will have nucleus, where you will have neutron, proton. Neutron is neutral, proton is positively charged, and outside this nucleus you will have orbits where you will find the electrons. You will find the electrons coming around the nucleus. So all this put together is one atom. So every particle is made up of atom. Each atom will have proton, electron, neutron. Inside the nucleus, center of the atom, you will have proton, neutron. Outside the nucleus, you will have electrons. Okay. Now some materials. Okay. Let's take copper, or let's take iron. The electrons in the last orbit, they can freely move out. They can freely move. Okay. There are some materials where the electrons are tightly bound to the center. Okay, that is one set of elements. But there are certain elements where the electron in the outer layer will be available free. It can freely move out and come. So for example, copper. So now what happens, I will take a copper wire. I will take a copper wire. I will connect it to the battery. I will take a copper wire. This is copper wire. I am connecting to the battery. So once the copper wire is connected to the battery, and you know copper has free electron, all these free electrons, the moment it is connected, it will start moving in a particular direction. These electrons will start moving in a particular direction. This movement of these free electrons, that is current. That movement of free electrons, it is current. So some materials like copper, iron, they will have free electrons, and other materials may not have free electrons. For example, most of the metals, okay, they will have free electrons. The metals can conduct electricity, because movement of these electrons is a current. Movement of electrons is what is current. Okay, so electrons to move, there should be free electrons. So those materials which has free electrons, they are called as conductor. They are called as conductor. And those materials which is not having that free electron to move, that is called as insulator. So if you take a copper wire, you take a wire. So the innermost part, so here we will have the actual copper material. Outside that you will have materials like rubber, because rubber, glass, these are bad conductors. You will not have that free electrons. But inside the copper wire, that is going to have free electrons. Once that wire is connected to a circuit, once it is connected to a power source, the electrons will start moving at a greater speed. The electrons will start moving at a greater speed. Okay, so that movement will constitute current. Clear? So now you got what is a conductor. So conductor is a material where there will be free electrons. So the electrons moves, that results in current. Now I said copper is also a conductor, iron is also a conductor, other metals are also conductor. But why we are choosing copper for all electrical appliances, for all wiring purposes, we use copper wire? What is the reason? The reason is, see, when these electrons are moving inside that wire, imagine when the electrons are moving, there will be resistance. There will be something which will block the flow of electrons. There will be resistance, that is natural. Every material will have some resistance. Copper wire also has some resistance. that material has resistance, that resistance will check the movement of the electrons. It will slow up the movement of electrons. So copper relatively has lesser resistance. Copper has lesser resistance. Iron has more resistance. Copper has lesser resistance. So this lesser resistance is the reason why we are using copper for providing wiring for electrical appliances. I hope you got some idea. Now imagine a long transmission line. Imagine a long transmission line. So the transmission line is huge. See, we see overhead power transmission lines. So you will have conductors. So in one side we give power, another side we will receive that power. That power, electricity is conducted through this wire. But however, in this process you will have lot of resistance. The wire will have, the material will have resistance. That resistance will result in loss of current. For example, in one side you are giving 100 units of power. In the receiving side you will be receiving, let us say, 70 units of power. There will be power loss. So when you are conducting power from one point to another point, since the wire, the conductor has resistance, the electrons movement can be reduced, the speed can be reduced. So that results in lot of loss. Right? So resistance is a problem which conductors, which all the conductors, they have this problem of resistance. Now how it would be if we reduce that resistance? Say a copper wire has some resistance. If I am able to reduce that resistance, then there will be more free movement of electrons, so that there is reduced loss. There is reduced loss, right? So how to reduce the resistance? To reduce the resistance, there are two ways. One is you lower the temperature. If you lower the temperature, or you have to increase the pressure. Either by lowering the temperature or by increasing the pressure, you can reduce the resistance. You can make it almost zero. But how much temperature you have to reduce? You have to achieve some minus 250 degrees Celsius. So if you want to achieve zero resistance, then you have to maintain an external temperature of around minus 250 degrees Celsius. Right? Or you have to increase the pressure, very high pressure you have to increase. So both, achieving both is going to be challenging, right? So what is the biggest problem we are facing? Transmission loss we are facing. One side electricity is generated, that is being transmitted to several cities, several states. In the transmission process, the wire which is conducting the electricity will have that resistance will reduce the current flow, there will be loss. If we achieve zero resistance, the transmission loss will become zero. But to achieve that zero resistance, you have to lower the temperature. How much? You have to achieve minus 250 degrees Celsius. So that is going to be challenging. That is going to be challenging, right? But however, recently, researchers from South Korea, what did they do? They took lead, oxygen, sulfur, phosphorus, they fused all these elements at a very high temperature, and they developed a new material which is called as LK99. It is called as LK99. They were able to get a grey color material, LK99, and the South Korean researchers, they are claiming that this material can achieve superconductivity. What is superconductivity? So when you achieve zero resistance, then whatever input you give, that is what you will get at output. There will be no power loss. The transmission loss will be zero. That situation where resistance becomes zero, that is called as superconductivity. But to achieve superconductivity, usually we need lower temperature or higher pressure, which is very, very costlier to achieve. But South Korean researchers, they are claiming that they have developed a material made up of oxygen, lead, sulfur, phosphorus, and that material is having superconductivity property. That is, even at room temperature or even at 100 degrees Celsius, even at 120 degrees Celsius, in room temperature or 100 degrees or up to 120 plus degrees Celsius, this LK99 material is exhibiting superconductivity. They are claiming. Traditionally, what we know, certain elements at minus 250 plus degrees Celsius, they will have zero resistance. But South Korean researchers are saying that they have achieved a material, that is LK99, which will exhibit superconductivity even at room temperature, even at a higher degree Celsius, like 100 degrees Celsius also. If the temperature is 100 degree outside, still this LK99 will exhibit superconductivity. See, if this becomes reality, if superconductivity at room temperature becomes reality, the applications are so huge, phenomenal application. First one we all know, the electricity transmission loss will become zero. So you can conserve a lot of power, right? And also see this resistance in the conductor, you have resistance. That resistance will prevent or it will hinder the movement of electrons. Electrons are moving, there is something resisting the movement of electrons. That resistance will create heat, right? So all our electronic appliances, if more heat is produced, right? I am charging my laptop, right? There is some resistance, heat is produced. My electronic components, it also needs power supply, right? Heat is produced in the electronic components. That heat is because of resistance. That heat will reduce the functionality, capacity, efficiency of my laptop or iPad. So if superconductive material is available, then that heat will not be generated. My computing speed will improve. My computing efficiency will improve. MRI scan, that MRI machine has superconductivity based materials, right? So it needs to achieve that superconductivity properties for taking the MRI scan. Okay. So since MRI scan involves such complex phenomena, it is more costlier. So if we are able to achieve superconductivity at room temperature, then various diagnostics will become so cheaper. MRI scan will become so cheaper, right? Bullet trains, right? We can achieve very high efficiency in the speed of bullet trains because of superconductivity, right? So the applications are wide. There will be phenomenal improvement in our entire electrical electronics appliances, right? So yes, this is about LK99, but one section of the scientific society is slightly skeptical about this achievement. They say that we have to test it whether LK99 really has that property or not. But however, South Korean researchers, they claim confidently that LK99 has achieved superconductivity, right? So this is about this topic. I hope the video was useful. So tomorrow, before that, yes, I will show you the content. So you can pause the video, you can go through the information about superconductor, why it was in news, right? So it is a mix of lead, oxygen, sulfur, phosphorus. Even at 127 degrees Celsius, it can achieve that zero resistivity. So how it is useful I have given here. You can go through these slides. I will see you tomorrow. Till then, bye. Take care.